Hello again everyone. So quite a few people have asked what the impact of fitting a 20 valve to a Boxster is in terms of weight and also the balance of the vehicle after it's been fitted. So I've put together a really short deck. We're just going to run through it now and hopefully this will help explain that. So when we talk about weight, we're really talking about the all-up vehicle mass, and of course when it comes to fitting an 1.8T 20 valve with the booster repower kit, we're going to reduce that by around 50 kilos versus the standard car. And 50 kilos is an appreciable amount. So the Porsche published wet weight minus fuel for the vehicle is between 1,250 kilos and 1,320 kilos. So retaining all the interior and everything else, you've got good options for getting further down towards that 1,200 kilo mark, which is incredibly lightweight for a high performance steel bodied vehicle. But the key is really retaining a front rear weight distribution that's similar to the original 986 with the M96 engine, because that means that the handling feel and the balance of the vehicle also remains the same. So we'll have a close look at the numbers of the standard 986 with the M96 engine and a 986 with an 1.8T 20 valve that's been fitted using the booster kit. So here's the standard car. For this standard car, we're using a 1999 2.5 litre base spec UK variant, so right hand drive with all the fluids in it except fuel. So fuel tank is dry, but engine oils are present, so on and so on. And for this we can see that comes out at 1,275.8 kilograms, and this is a measure taken of the original car that we have used for the validation prototype. So this is real world measurement of the before of the same vehicle that we're talking about. And we can see that we have a 47% of the mass on the front axle and 53% of the mass on the rear axle, which is exactly what Porsche published 20 years ago, showing what the weight distribution of the standard car was in various press articles and similar. So pretty sensible, nice balance, not too rear biased, almost 50-50 with a little bit of rear bias to it. So it's going to handle really nicely. It's going to be quite balanced, but it's going to want to rotate a little bit more than a car with a 50-50 weight distribution would, which is good because you want that. It's what a sporty car is. So now let's have a look at what it looks like with the 20 valve in it. And here we can see the 20 valve in the vehicle are all at mass. And again, this is the same vehicle that we've seen on the previous page that we've taken the M96 out of and put a 20 valve into. Same UK variant, 2.5 litre. This has got all the fluids in it except fuel, exactly the same as last time, but in this example we don't have the spare wheel and toolkit in the nose. So all up mass is 1,224.5 kilograms, so quite significantly reduced versus standard. We can see a front axle mass of 582.6 kilos and a rear axle mass of 641.9 kilos. And what that translates to is 47.58% of the weight on the front and 52.42% of the weight on the rear. And we can see that's made essentially no difference to the distribution. So when we look at this a little bit closer, what you really want to see as well is what has that meant for the centre of mass. And the centre of mass is where that balance point is in the vehicle. So we know that we're a little bit lighter overall. We know that it's moved the front rear balances by 0.6%, essentially zero. But what does that mean in real physical measurable terms? Well, we can work that out pretty easily. We know that the standard M96 powered car has a wheelbase of 2,480 millimeters. And of course, we've not changed that by putting the 1.8T 20 valve in, because we use the same gearbox mounted on the same plane as it always was. So the gearbox doesn't move in the vehicle. So we haven't changed any suspension elements or similar. The wheelbase is the wheelbase still. So when we run a quick calculation on this, we can see that with the M96 engine, our centre of mass is 1,136.2 millimetres in front of the rear axle. And with the 1.8T 20 valve, our centre of mass is 1,150.5 millimetres in front of the rear axle. So we're talking about a difference of 14.3 millimetres, which is about the same as if you move the driver's seat forward one click. So again, functionally nothing. But the thing is corner weights. because this has been brought up a few times when we talk about putting an inline four with a big turbo hanging off one side of it into a Boxster. People always say, well, a flat six is symmetrical, so it's going to have symmetrical weight. And it does. You know, a flat six is architecturally a really well-balanced solution, and quite often inline four-cylinder engines aren't. And we looked at how we could address this when we were really laying out what that 0.6A 20V powertrain installation looked like in the vehicle. So because we have a heavy side, exhaust manifold and turbocharger, we have balanced this by packaging the charge cooler and various other things, alternators, pass pumps, which are in the standard location for the 20V, but they're nicely on the inlet side of the engine. And by doing that, we can get the engine pretty well balanced. It's nice across the crank centre line. So on the right hand side, we can see a set of corner weight scales, which are showing the corner weights for our validation prototype car, which has a GT3076R turbo, a teal external wastegate, and a generic T3 cast exhaust manifold. And on this car, we're using the Hanon Systems McLaren 570S GT4 charge cooler. And the weights here are shown with 35 kilos of fuel in the tank. We can see that our corner weights at the rear are within 1 kilo, and our corner weights at the front are within a little bit more than that, about 8 kilos, but that's because it's a right-hand drive car and our pedal box and steering wheel is on that side. So how have we managed this? Because obviously you think you take 50 kilos out the back of the vehicle, you're going to move those balance points, that centre of mass, by quite considerably more. But you're not, if you employ some good engineering. So when we designed the engine mounting system to allow us to put a 20V in a Boxster, we did so on the understanding and with the plan that we didn't want to move the balance of the vehicle, the centre of mass, significantly. And our original target was 1%. We wanted to be within 1% of what the vehicle was originally. We're actually at 0.6%, so good result. But the way we've achieved this is by the way that we have engineered and designed the front engine mount system. So we have engineered an engine mounting system that picks up on the original mounting points on the 0.6A block, but then translates it into what we call a tombstone mount. So it's a vertical billet aluminium piece which translates the 0.6A mounting points to the original location of the Porsche M96 front engine mount. But when we designed the tombstone mount, we knew that we had to do something here to move the mass balance forward. So we designed it with a lot of extra material in it to function as ballast. So the tombstone mount acts as ballast in that location in the engine bay. It's very far forwards in the engine bay and it's low down in the engine bay, which means even though we're not adding 50 kilos back, we're moving mass further forwards in the bay, which brings the centre of balance of the car, or centre of balance of it, forwards. It doesn't bring it all the way forwards to what it was, but it brings it extremely close. So, as we saw earlier, within 14 and a bit millimetres. So we end up with a vehicle which is still really nicely balanced. You would be hard pushed to tell that there is any difference in balance versus the standard car. And of course, that means that the handling and the benign handling elements of the vehicle are exactly the same as they were with the M96 engine fitted. So I hope that was interesting and explained a little bit about how we've engineered this and how we've kept the masses sensible and the impacts it has on corner weights, etc. The vehicle with an 0.6A 20V fitted via the booster kit is still incredibly balanced. It's a really lovely thing to drive. It drives just like a 986 always did, but with twice the horsepower. So if you want more information, have a look at 986booster.com, which details anything and everything about the kit. And you can also watch our 40-minute long sort of deep dive on how we developed this and what the kit contains, etc. And I'll put a link to that in the description. Thanks everyone. Cheers for watching. Bye for now.